we are going to break into components. You should read the front of this. You should read the front of this. It shows you how to do it, step by step, what to do. And then try the back of it yourself. Here's 2 more solved examples. Try it yourself. And then to check your answers, watch the rest of this video. You can just, if you think you got them, you can just fast forward and check your answers. If you need help, watch the whole video. I explain it to you.
Okay, we're going to break a vector into components. So you can see we're starting with 235 units. That's the magnitude of it. That's how long the arrow is. At 120 degrees. That's the direction. First, I'm going to make a sketch. I looked at it and I knew that 120 was going to be over here in the second quadrant, so I drew that bigger. If you're not sure where it is when you start, just draw these even. I kind of take a little time to think whether it should be, this should be the smaller angle or this should be the smaller angle. I knew this was 120, so that's 30 degrees past the 90, so I made this the smaller angle. The length of that is 235. And now that's the important part. Pick an acute angle to label. I did not label anything 120. Remember, I'm trying to make a right triangle. There's not going to be a right triangle that has 120 degrees in it. So I marked, this is 30 degrees. It's 30 degrees past the 90. That's an important step that people will screw up. I draw my rectangle, or my parallelogram, where this vector was the diagonal of it, and that shows me how long to draw my components. I know you can probably get the right answers with not having a good sketch, but we're building a skill here. We're building a skill for when we start our free body diagrams later in Chapter 4. I call this component Y because it's on the Y-axis. I call this X. You could just call A and B or whatever you want to call it. So that's what I'm trying to do. I'm trying to find the length of this and the length of this. Since I marked this angle was 30, you can tell I'm looking at this triangle. I could have marked this angle 60, and then I would have been looking at this triangle, and that would have been fine. I'd get the same answer. It really doesn't matter. So looking at my triangle now, you can tell that Y is the adjacent side, and 235 is the hypotenuse. And it's a rectangle. If that side is x, this side is the length of x, and that is the opposite. So I'm just using my trig functions to find the length of those missing sides. I can find x. X is the opposite side. 235 is the hypotenuse. So if I put x over 235, now I do is cross multiply sine of 30 times 235. I kept 3 sig figs on my answer. And now for the direction, I just look at my picture. You can tell, x is pointing to the west. My direction is west. There's my one component. And now if I want to find y, y is the adjacent side. Adjacent over hypotenuse. Now I will always go back and use this original number. I will always go back and use the hypotenuse. I'm not going to use the opposite side that I just found because I've rounded that a little bit already. So I'm not going to use tangent to find this. I will always use cosine to find it. I'm going to use this original piece of information. Again, now I just cross multiply, and then I look at my picture to get my direction. Now remember, I'm building a good skill here. Make sure your vectors are arrows, not just lines. And make sure it looks like you have a rectangle. That's the only way you're going to get a right triangle, because sine, cosine, tangent only works for right triangles. Let's try example B. Okay, you can tell this is an entirely different scale. This time it's only 6.9 units long. Remember, these could be any vectors. If this was displacement vectors, that'd be 6.9 meters. If they were force vectors, it'd be 6.9 newtons. If it was velocity vectors, it'd be 6.9 meters per second. Right now we're just learning the math of vectors. At 208 degrees, you can tell that's a little, it's going to be past the 180, so I'm going to be down here in the third quadrant. So I'm just drawing the third quadrant real big. Now I think about where to draw this. 208. It's going to be 28 degrees past the 180. So it has a length of 6.9. And I have to label this acute angle 28 degrees. Now I can draw my rectangle. Straight over, straight up. All my tails together. So this one points down. This one points to the left. I call that X for X-axis, Y for Y-axis. Since I labeled that to 28, you can tell I'm looking at this triangle. This time X is adjacent. And if that side's Y, this side is Y. And Y is the opposite. And 6.9 is my hypotenuse. You can tell that's different than last time. So my opposite side is what I use with sine. In this case, my opposite side is the Y. In example A, my opposite side was X. So that's another people will screw these up. Make sure you're looking at a triangle when you're doing opposite over hypotenuse and adjacent over hypotenuse. I cross multiply. I look at my picture and I see Y points down, so that is south. My adjacent side is X, so adjacent hypotenuse. So I'm looking for the length of X. I cross multiply. I look at my picture and I see X points to the west. Do not just watch this video and write on your paper. Try the next one yourself before you hit play. Make sure you have a calculator and you're punching along and you can get these yourself. Because remember, different calculators work a little differently. Sometimes you have to put the sign in first. Sometimes you have to put the 28 in first. You need to know how your calculator works. And I'm over here in fourth quadrant. I thought about that before I drew it. It's pretty close to the middle. The length is 235. And this is 49 degrees past the 270. 270 and 49 more. I could have taken 319, subtracted 270. That's why I knew this. Or I could have taken 360 minus the 319, and this one would have been 41. And that's fine. I could have done that instead. But I need to know one of these two angles, because that's the direction this is pointing. So since I picked that, you can tell I'm going to look at this bottom triangle. I draw my rectangle, so I know how long to make my components. X for x-axis, y for y-axis. I'm looking at this triangle. 235 is the hypotenuse, because that's the right angle. If that side's x, this side is x, and that's the opposite in my yellow triangle, and this is adjacent. I know when I break into components, it's always going to be sine and cosine. You might want to just set it up like this. You know they both have a hypotenuse on the bottom, and that's 235. And now I go back and look in my triangle. Sine is opposite over hypotenuse. So I can see in this triangle, my opposite side is x. And cosine is adjacent. In this triangle, my adjacent side is the y. It's next to the angle. Now I just cross multiply for both. And I look at my diagram for direction. X points to the east. and y points to the south. $278. That's just a hair past the 270. Don't draw a rectangle like that. There's probably somebody that did that. You might get the right answer, but your diagram looks like crap. Draw it right, so then when we get to chapter 4 and make free body diagrams, you have some decent looking diagrams. There, a skinny little triangle. And that way, when I check my answers, I know that my x should be a lot smaller than my y. The magnitude is 61.3, and that would be 8 degrees, because it's 8 degrees past the 270. So I'm looking at this little triangle. I'm breaking into components. I know it's sine and cosine. I know my hypotenuse is 61.3. And now I look at my triangle. Sine is opposite. Opposite in mine is x, adjacent in this one is y. I look at my picture and x points to the east. I look at my picture and y points south. $155. So over in quadrant 2. I didn't make to the 180. 180 minus 155 can give me this angle. It's 25 more degrees, and I'd be at the 180. I'm making a rectangle. X-axis. I'm looking at this triangle. If that side is y, this side is y. I'm breaking in components, so I know it's going to be sine and cosine. My hypotenuse is 835. I look at my triangle and I see that my opposite side in this triangle is a y. My adjacent in this triangle is x. Got my magnitude is 353. My direction is north. My magnitude is 757. My direction is west. Just one more. 1.25 at 38 degrees. So this is easy. This is up in quadrant 1. 38 degrees past the 0. 38 from the 0. Straight down, straight over. Shows me how long to draw my components. Y-axis, x-axis. Everything's an arrow pointing in the correct direction. All my tails are together. I'm looking at this triangle. Opposite has a length of y. I'm breaking into components. I know it's sine and cosine. My hypotenuse is 1.25. Sine is opposite of our hypotenuse. My opposite side is y. My adjacent side is x. I cross multiply. 0.77? That's too small. Doesn't that seem like that's too small? No, a lot of people do that. If this is only 1, this is a little over 1, yeah, I can believe that's 0.7. That's less than 1. So don't just look at an answer and say, oh, that's too small. No, it's not. My y points north. Cross multiply. My magnitude with 3 sig figs, 0.985. And looking at my picture, my direction is east. And that is how we break into components.